Use De Moivre's theorem to find the indicated power of the complex number. We'll write our results in standard form. The first thing I need to do is find the radius. And the radius is the square root of x squared, which is negative 1 squared, plus rad 3 squared, which equals 1 plus 3, and the square root of 4 equals 2. There's the radius. Then I need to figure out the tangent, or the angle. So the inverse tangent is rad 3 over negative 1, which equals negative pi thirds. So we're going to go ahead and set this up now. We have 2, which is the radius raised to the n, which is the 12th power, cosine of 12 times negative pi thirds, plus I sine 12 of negative pi thirds. So when we reduce this, I get the cosine of negative 4 pi plus I sine of negative 4 pi. The next piece I'm going to do here is I'm going to find my coterminal angle. So I'm going to add 2 pi until I hit between 0 and 2 pi. So this is 2 raised to the 12th times the cosine of 0 plus I sine of 0. Now 0 or 2 pi, the terminal point is 1, 0. So I'm going to replace cosine with 1, and I'm going to replace sine of 0 with 0. And 2 to the 12th power is 4,096. When I distribute this in, I get 4,096 plus 0, so standard form would be 4,096. The first thing I need to find is the radius. So that's 1 squared plus 1 squared, and the radius is the square root of 2. Next, I have to find the angle. So the inverse of y over x equals, where is tangent 1? And it's 1 at 45 degrees, or pi fourths. All right, so we're going to set this up. We have rad 2 raised to the 6th power times the cosine of pi fourths plus I sine 6 of pi fourths. And I forgot the 6 over here, so I'll add it in now. When I simplify this down, I get rad 2 to the 6th power times the cosine of 3 pi halves plus I sine of 3 pi halves. Now 3 pi halves terminal point is 0, negative 1. So I'm going to replace the cosine with 0, and I'm going to replace the sine with negative 1. When I simplify this piece right here, I get 8. So 8 times 0 is 0, minus 8i. So my final solution here is negative 8i.